One of the most versatile ways to make a carbon-carbon bond is to employ an organometallic Grignard reagent. This starts with an organic halide being treated with magnesium metal, which react together to give the Grignard species. An aldehyde or a ketone is then added, with the Grignard nucleophile attacking the carbonyl carbon. The resultant alkoxide is then quenched, and an alcohol product is the result. The reaction begins with the insertion of the magnesium into the carbon-bromine bond to give the nucleophilic Grignard reagent. This is polarized such that carbon is highly electron-rich. Adding an aldehyde or a ketone allows for nucleophilic addition to occur to generate a new carbon-carbon bond and an alkoxide. Addition of acid at this point provides the alcohol product. The formation of Grignard reagents is quite general and requires a suitable alkyl, alkenyl, or aryl halide. This is then reacted with magnesium metal in a polar aprotic solvent such as ether. The magnesium donates its 2 electrons to carbon to give the nucleophilic Grignard reagent. Addition of a carbonyl in the form of an aldehyde or a ketone allows the nucleophilic carbon from the Grignard reagent to attack the electrophilic carbon of the carbonyl in a nucleophilic addition. This results in an alkoxide in which the electron density has been passed from the unstable carbon nucleophile to the more electronegative oxygen. In this case, a racemic mixture of alkoxides is formed because a prochiral aldehyde was used as starting material. The last operation in this procedure is to quench the alkoxide anion. Acid is added to neutralize the very basic reaction mixture, and the resultant alcohol product is then isolated. Starting with aldehydes provides secondary alcohols, whereas using ketones would provide tertiary alcohol products. Overall, this is a quite general and very versatile way to make carbon-carbon bonds. By beginning with an organic halide in a polar aprotic solvent, adding magnesium metal to give the Grignard reagent, and then an aldehyde or a ketone represents a very powerful way of constructing complex products through nucleophilic addition. Quenching the alkoxide product provides the alcohol that is then isolated.